Here we go. 3, 2, 1, and here we go.
All right. So this one I may have to talk you through, if
Is this
that's
just-
okay.
So critical points, is this like where it intersects this axis or?
If it were the derivative, yes, but because it's the original function, it's just a max or a min.
Oh, that's just E, D, and B.
Yes.
All right.
Okay. Local maxima.
So maximum, so just D. With a local minima, EB. Done and done. There we go.
That was great.
Alrighty, how many critical points are there? How many are local maxima? How many are local minima? So basically the same.
So it looks like if you just count there, you got 1, 2, 3.
3, 4.
It looks like 4. Looks like 2 are min and 2 are max. There's 2, sort of peaks, 2 valleys.
Mhm.
I like that question. Get more of those.
Yeah. All right, let's see. We had a fever, rose steadily, then went down for 28 hours. Was there a critical point for his temperatures as a function of time? There was after the first.
So they're asking you to like logic through what the sentence is saying, which is that like the function rose and then it went down.
Yeah.
So if something increases and then decreases, it must be a maximum. Now, where is it? It's wherever the change took place. So it was after 22 hours is where it hit that max.
Oh, it really is that straightforward. Okay.
Yeah. Okay. Now this one requires more effort here. I'd like to snip this in if you're okay with that.
All good.
And then what does it say? They're critical points, then classify critical points. Okay. So let me snip that in. Now I'll share my screen. And we'll get started on some new stuff here. Let me go grab that. Sorry, there we go. Yes. Yes. Okay. So the critical points come from taking the derivative. So the derivative of this function is 4x cubed minus 144x. And I'm just using the power rule.
Okay.
So it's no longer good enough just to know the derivative. You're going to use the derivative for something. You factor out what's common, the greatest common factor, and you get x squared minus 36.
Okay.
Okay. And then this is your prerequisite stuff. This is, okay, I know how to factor difference of squares and I'm really fast at it. At least that's what they're thinking when they assign this problem. So the critical points are where each of these equals 0. So where 4x equals 0, where x minus 6 equals 0, and then where x plus 6 equals 0.
So plus minus 6 here.
0, 6, and negative 6. They think it said something about putting them in like increasing order. So maybe like that. Okay, and then the next thing you have to do here, and this is where is you have to build a sign chart, and I just use a number line. So this number line represents the derivative, and you have a critical point, negative 6, 0, and 6. And then you have to create what are called test points. You're testing a point in each region, and you're testing it back in the derivative. And this helps you to figure out whether it's a min or a max. So for example, let's say we wanted to test -2, +2, 8, and -7. It really doesn't matter as long as it's in between there. So you take each of these numbers and you have to put it back into the derivative. And what most students do is they actually calculate the number, but you only need to know whether it's positive or negative. Okay, so what I mean by that is, like, let's put 8 in. 4 times 8 is positive. 8 minus 6 is positive. 8 plus 6 is positive. A positive times a positive times a positive.
Positive. So f of x is greater than 0 here.
It's positive there. F prime of x. This is the derivative.
Oh yes.
Okay, and then you do the same thing for 2. So 4 times 2 is positive. 2 minus negative. 6, positive. So positive, negative, positive. That's negative. And you continue on. So you have a negative, and a positive. So this becomes positive. And then the last one here is negative, negative, negative. So it's negative. it does not always alternate like this. It will in the first few, but in general, it does not. So there's some
Wait, when
rules.
it's a -6 to 0, when you plug in -2, it would be negative.
I get that this is negative, 4x
Oh,
is
oh,
negative.
never mind. I
That's,
forgot the 4x.
yeah,
Okay,
yeah.
you're right.
Okay. So now the rules. So the rules are, if you go from minus to plus, this is a min
Mhm.
because the function's going down and then back up. Plus to minus is a max.
Okay,
And then the ones you don't care about, minus to minus is nothing. And same with plus to plus. These are nothing. So I didn't snip everything, but in your question there, but I believe you have to insert each of these points. So like -6 is I'll use a different color here. It's because it's going down then up. This is a min. 0, it's going up and then going down. So it's a max. And then down and then up, that's another min.
okay. Oh, okay, so for x1, will it be like -6, then 0,
Yes.
then 6? Okay,
Yes.
I'm making sure that I'm doing that in the correct order. Okay, so -0, -6, I mean, and then 0, and then 6.
Yeah. And you're welcome to share your screen at any point here to have me help you guide the entry of
Alright.
the answers, but you probably have it down.
Right here. And do I put this in order again, like right here?
Yes. Yes.
Okay. And then 6, and this is a
First one was a min,
okay, minimum, and then maximum,
max, and then a
then
min.
min. Okay,
And again, they don't always alternate. It just happened to be the case for this problem.
okay.
Okay. So let me snip this in. This is really similar to the last one. It's it's a bit of a working problem. You got a lot of steps here. You do repeat them for these problems, but definitely understand if you need to see a few of these before you're like, okay, I think I'm ready to try one on my own. So let me share my screen and switch to red. I don't like red, but the derivative is 30x to the 4th minus 120x squared.
And
That's
then you
how fast.
factor out, right? Then
Factor out
30x squared.
30x squared. So you get an x squared minus 4. These tend to factor really nicely because they're not trying to like emphasize the algebra. They
They
just
want the calculus.
calculus. So you set each of these equal to 0. You don't have to literally set them equal to 0. Like you could say, all right, it's 0, 2, and -2. Like
Mhm.
that's fine with me. I don't think your instructor really wants you to spend like a lot of time writing it out. They want to see the calculus though.
Mhm.
Okay. So now it's the more difficult part, which is like, okay, we got to figure out where it's increasing or decreasing. I strongly recommend using the sign chart here, the number line, and you label them. I'm not like trying to get them. It's just relative, like -2 is left with 0 and 2 is there
Mhm.
to the right. So now you create test points.
Mhm.
And sorry, let me just get a little more room here. So I'm just switching colors in case you want to go back later and look at this. Choose easy numbers, like 1 is an easy number, 3 is an easy number. You could choose like -5, that's fine. But again, you're going back to this factored form. You always want to use the factored form because you're trying to figure out the sign. So the sign of this is, let's do the 3. 30x squared is always positive because you square a positive, you get a positive, square a negative, you get a positive. 3 minus 2 is positive, 3 plus 2 is positive. So this is positive. You never check the critical point. I'm not sure why this even gets brought up, but if you check the critical point, you get 0, and that's the point. That's why it's a critical point. So when you try 1, 30x squared is positive, 1 minus 2 is negative, that's positive, that's negative. And again, like it does in this one, it does alternate, but please don't make that mistake. Actually, let me take that back here. -1, positive, negative, positive. So that one actually is negative. So this one is an example of where it doesn't, and that is
Mhm.
positive there.
So it's increasing for, so
it's increasing. This is different. It's increasing wherever you have a plus. So
okay.
it's minus infinity to -2 because that's this region over here, and then
Mhm.
also comma 2 to infinity because that's where the plus is over here.
Okay.
And the plus meaning like increasing or decreasing. Decreasing from -2 to 0, comma 0 to 2. Now it may just combine those. I don't really know what your system we'll see, but at 0 it's neither increasing nor decreasing, but it doesn't
This one looks a little weird. I'll screen share real quick.
Okay.
These are what the answers will look like.
Okay, so they're just using inequality notation. So instead of -infinity to -2, it's x less than -2, comma x greater than 2.
Oh, okay. For
Well,
for increasing.
That's for increasing, yeah. And then for decreasing, it is between -2 and 2, which I guess is there.
This again.
Between -2 and 2.
Oh, like right here.
So
Oh.
yeah, so the compound inequality. Great. You will be expected to do what I'm doing right here on a tester quiz. Like this is nice, but it's not gonna be on there. So all right, so we're looking at a different function here. Local max, local min. Let me grab it, snip it in, work this out here. All right, share my screen. All right. So the G prime of X, well, let me go back. So G of X, and we were doing these last night. G of X is a product rule.
Okay.
So your U is X, U prime is 1, V is e to the -4x, V prime, the derivative of E is itself, exactly what you see, times the derivative of the inside function. The inside function is -4x. So the derivative of that is -4. And because we're using it, you might want to simplify there. So your derivative product rule is U V prime plus V U prime. So that's X times -4 e to the -4x plus e to the -4x times 1. And just a little bit of like rewriting here to get it kind of nice. Okay, this is your derivative, but they're no longer just asking for a derivative. You have to set the derivative equal to 0. And you're almost always going to factor.
Okay.
So you're gonna factor out e to the -4x. So you get -4x plus 1 equals 0. You set
Okay.
each of these equal to 0. -4x plus 1 equals 0. Now on the left here, this is never 0. So whenever you have something with an e, it is never 0. Never, 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 never. Okay. So on the right, you saw for x is 1/4. This is the only critical point, the only one. So you draw your number line here again, and you put 1/4 there, and you got a test. So like keep it, because you may not have a calculator, keep it nice, like try 0, try 1. Don't just pick like 10. Pick a number like you can actually work with back in this line right here. So we're working back in this line right here. And since e is never 0, it takes on the sign of whatever's out in front. So if there's a negative out in front, then it's always negative. If it's a positive out in front, then it's always positive. So when you test 0, you could go e to the 0, okay, and that's fine, but it's always positive because there's a positive out in front. -4 times 0 plus 1 is positive. So this right here is a positive because you have a positive times a positive. 1, when you put 1 in, yeah, it's e to the -4, but it's positive because there's a positive in front. -4 times 1 is -4 plus 1 is negative something. Positive times a negative is a negative. So when you go from increasing, which is what you're doing here, you're increasing, and then you're decreasing. This is a max. So your local maximum is x equals, when you go back to like, well, what do I put here, Matthew? It's right here. It's 1/4. But all this work went into that. And the min, there is no min. I don't remember what it said to put in there. I guess NA.
NA.
Okay. And it's Like this level of like analysis is needed, like if you want to do well in this class. So just warning you now. All right, so another kind of just another one of these problems here. Grab it. All right, so let me share my screen. Let's try green here. So the derivative here, this is really u over v, and u is x, u prime is 1, v is x squared plus 9, v prime is 2x. So your derivative is bottom times derivative of top minus top times derivative of the bottom over the bottom squared. You have to be able to like quickly recognize what it is and then apply the formulas and then work it out here. So vu prime is 2x times x minus u, which is, oops, I already messed this up. So it's x squared plus 9 times 1 minus x times 2x all over x squared plus 9 squared. You do have to simplify this right here. This minus 2x times x is minus 2x squared. You got an x squared over here and you got a 9. So it ends up being 9 minus x squared up top over x squared plus 9 squared on the bottom. I know it's not great. It's a lot of work. And this is where the course really like increases in difficulty. So you set this equal to 0 because that's how you find the critical points. You only find critical points when you set it equal to 0. When you have a rational function like this, you only set the numerator equal to 0. So you set 9 minus x squared equal to 0. You can move things around. You can factor. It's difference of squares. You've got to get both of them. So it's -3 and 3 are the critical points.
Oh, okay, so these x's will just be 3 and -3.
Yep.
For the x's.
Yep. And so now we got to test points, but we got to test them back in this 9 minus x squared over x squared plus 9 squared. And when you're testing, you gotta find ways to make it like faster. And one way you make it faster is you recognize like, okay, the bottom is always squared, so the bottom is always positive.
Okay.
So whatever the sign of the numerator is, that's what the sign of the thing is. Because if it's negative, a negative over positive is negative. If it's positive, positive or positive is positive. So when you put 4 in, 9 minus 4 squared is negative. That's negative there. When you put 0 in, you get 9, which is positive.
Mhm.
You put -5 in, you get 9 minus 25, you get a negative. So again, you have to realize like, well, what do these signs actually mean? Like it literally means that the function is decreasing and then increasing. So that's a min because it's coming down and then up. Like you'll see yourself maybe on a test with your pencil or people see with their finger, and then it's increasing and then decreasing. So that's a max. It's going like that.
Okay, so the max is at the 3 and then the minimum is at the -3.
Yes.
Understandable.
Now this one has a little extra little wrinkle to it. It says, oh no, I'm sorry. It doesn't, this does not. Eventually it's going to ask you to calculate the Y value, but we don't need it for this problem. Okay, so the critical point is where the derivative equals 0. So which one of those 3 bullet points is the derivative?
Of these?
Yeah.
This is the first derivative and then the second, but for the coordinate plane.
So you said, here's what I just heard. The second bullet is the derivative. F prime of 4 equals 0. That's the derivative. That's a critical point because the derivative equals 0 at that point.
Oh, it does?
Yes.
Okay.
Now how to answer this. So the critical point is when x equals 4. Okay.
Oh,
Now
okay.
see how they all say 4 there in the
Mhm.
answer space? You gotta hit the drop down again. See how
This
they all
one?
have, see how they all, yeah, see how they all have, no,
How they on 4? Yeah, I see
Yeah.
that.
okay. So is it 4-8, 4-0, 4-3? Well,
4-0 right here.
you would think that, but it's asking now about the original function. The derivative is 0 at 4, but we want the actual ordered pair, which is at 4-8.
Oh, okay.
The critical point is, now
This
this is,
one, is this it?
yeah, and is it a min or a max?
It's
Okay,
neither.
how do you know?
Oh wait, no, you don't know.
Okay, okay, well, here's how you know. There's this thing called the second derivative test. Did you recall hearing about that?
I heard that.
Okay, so it's counter to what you would think, but if the second derivative at that point is positive, it's a min. So what is the second derivative? Is it positive or negative?
It's
F double,
positive.
it's positive, so it's a min. And I kind of liken it to like shifts left or addition, shift rights or positive. It's one of those things just backwards, but it's the way it works.
Which one is the best match? So F near the critical point.
So which one is a min? Which one of those shows a min? There you
Gotta be
go.
this one.
Boom.
All right, let's take a look at this one.
All right, let me grab this one. The University of Arizona is big on their math department, always has a lot of these symbolic questions. It's always been that way. Would love to talk to someone to find out like why they emphasize this so much. Because as a student, you're just like, I don't even know how to do this. So how do you expect me to do a symbolic problem when I'm starting out? So the way to find critical points is to take the derivative. So the derivative of this is its power. We're gonna bring the 2 down. So it's 2a x because, and then you subtract 1 from the exponent plus the
Plus B.
derivative plus b plus 0.
Mhm.
So you set it equal to 0. So you're setting 2ax plus b equal to 0, and you're solving for x. Sometimes you lose track of what you're solving for. X is minus b over 2a. So that's what they're looking for here.
Oh, it's just
And if you remember the quadratic formula, minus b plus or minus squared of all that stuff over 2a, now you know where it came from.
that is strange. I haven't thought about that. I was like, that looks very familiar.
Also the coordinates, the vertex. Anyway, we can say that for a time when we're not doing homework, but you kind of learn all these things, why they're true when you start taking calculus and other classes. All right, so let me definitely snip this in. This one appears to be symbolic, but this is an exam style question that you tend to see. So let's grab it here, and then I will share my screen. All right, let's see, share screen. Yes. Okay. All right, so it says find constants a and b so that the minimum for the parabola is at this point, 2, 10. Hint, begin by finding the critical point in terms of a. So you need to take a derivative. F prime of x is 2x plus a. Is that okay? Because that's just the derivative of this thing that's given.
Yeah, that's understandable.
You set it equal to 0, and you get that x equals minus a over 2. But they tell you that the critical point is right there when x equals 2.
Where do I
That,
set 2 in there? Okay.
yes. And there's this like interpretation you have to be really comfortable with.
So then 2 times 2, 4, and then divide by a negative 4.
Yeah, and you're like, great, I got that. How do I get the other one? So how do you get the other one? Let me rewrite this. So it's x squared minus 4x plus b. But this 0.210, it is not only a critical point, it's on the curve. So you can put 10 or 2 in for x and 10 in for y
Oh, okay.
and solve for b.
So then form is a okay. -4. So
Looks like b is
16. Oh, 14. Never mind.
14, I think.
I don't know why I got 16. Here we go.
Okay, so that's your kind of your good exam question, because you have to synthesize the information a little bit more. So definitely look at that again if you have time. All right, let me grab this last one for this homework. This one is kind of a symbolic one. Screen, there we go. So you gotta be able to take a derivative, and this is product rule.
Mhm.
We did a bunch of these last night. U equals X, U prime equals 1, V equals E to the AX. The derivative of E is always itself, but then you multiply by the derivative of the inside function, which is A. So it's A E to the AX. And if like really you don't like that, or you don't understand, you can just like put a number and you say, okay, what if A is 2? And you'll see it's the same thing. So your derivative, let me go, I need a little more room here. Your derivative is it's UV prime plus VU prime, or however you want to learn it. Maybe your instructor's using like F and G, but it's X times A E to the AX plus E to the AX times 1. So this is AX E to the AX plus E to the AX. And then to solve this, you factor out an E to the AX. So you have AX plus 1 here. You set these equal to 0. Remember that E to the AX or E to the anything is never 0, so you don't have to worry about that one. But you do have to solve for X on this one on the right. -1 over A.
And we're looking for A, right?
We're looking for A, and it tells you that it happens when X is 6. So it's kind of like the last problem. You set 6 equal to -1 over A, and you solve for A. A equals -1/6.
Oh, okay. First one.
You're probably noticing I'm skipping a lot of like algebra steps. That is the expectation, is that you like, you're
Already
not
know
like,
this stuff.
you're not like, oh, hey, how did you do that? And it's okay to ask in class, but don't be surprised if you get an answer. Well, it's why, it's why you took it for the classes. But what I would do as a student is I would just work out the problems again and really make sure I understood how to do it. Where
Yeah, Matthew, on Sunday, do you have any way that you can do some in-person lessons?
yeah, I can do one at 6 for sure.
Mhm.
Then if you need more than an hour, you just book it consecutively, I guess.
Yeah, because I got a practice exam thing that I can practice with you, and I'd like to kind of, since there's an exam next week, I want to be able to go over that and try to see how I can get through these problems by myself, and
Sure.
you could kind of help me
Absolutely.
shake up the problems if they're difficult for me.
Absolutely. Yeah. So right now I know I can meet at 6. I think there's some openings. If there's not, let me know. But
Do you think at the Whole Foods as usual, or is there
yeah,
another place that you're keeping in mind?
I usually just go to Starbucks or Whole Foods.
Okay, then I'll meet you then on 6 o'clock Sunday. Thank you
Oh,
very much for your time. I appreciate it as
you're welcome.
always.
Have
Have
a
a
great
nice
night.
day.
Bye now.
Bye bye.